Okay, so some of you have asked for more testing, so let's first of all see what kind of voltage drop we have over the spring. I have a little piece of nickel on both sides of the spring, so we will check the voltage on both sides of the spring and the load. So let's put on a 4 amp load. You can see we're pulling 4 amps, and the voltage before the spring terminal is 12.93, and after it is 12.70 to 12.84. It's about a 15 millivolt voltage drop over the spring, 15 millivolts at 4 amps. So we'll do some math on that in a second and see what kind of voltage drop that is, but 15 millivolts at 4 amps. Okay, so here is the second test. What I'm doing is I'm using a larger battery and I'm running the voltage through the spring clip. I have a little piece of nickel on the left and right side of the spring clip, and the spring is in its compressed form because I think that might be important because you get more contact between the springs when it's in its compressed form. So this is the way it'll be used in the box, so I'm running the current in its compressed form, but I'm not actually using this battery. I'm just using that battery to squish the spring. This battery is providing all the power. So pulling a little under 4 amps right now, and we can check the initial temperature. It's about 34 degrees on the spring, and I will run this now for 5 minutes and come back and check on it. Okay, so it is about 5 minutes later now. Let's see what temperature we read on the spring contact. 37. So it's gone up, there we go, 38 maybe. It's gone up 3 or 4 degrees in 5 minutes. So I think at 4 amps, it's clear that this is not really causing any issue. Okay, so trying to find a way to push 6 amp through the spring clip has been quite a challenge, but I finally decided to use a big battery to charge a small battery through this charge controller, and I'm running the current through the spring clip, through the voltmeter, which is in amp mode, and back into the small battery. Now obviously it's not a very efficient way of doing it. There's going to be a lot of loss between all these clips here, but let's see here. Let's see if we can push 6 amps through the spring clip. And before we begin, let's just check the ambient temperature here. It's about 31 degrees. Let's see what happens when we push 6 amps through this charge controller. Let's see what happens. Okay, and we're pushing now 6 amps. 6 amps is now traveling. 6 amps is over there. Spring clip is currently holding, no problems. It's not glowing red hot or anything. It is 32 degrees and climbing. We'll have to see. What happens. The problem is this battery is almost full, so the 6 amps are going to charge this battery up real quick, and the amperage is going to run down. But it's not red hot or anything at 6 amps, no problems. Yeah, it's currently 34 degrees with 6 amps running through it. And that's 6 amps at 12 volts. So yeah, I mean, I really think these spring clips are pretty good actually. I mean, we know that if you short circuit, they burn out, but they can take reasonable amperage. I mean, here they are. 6 amps is still running right through the spring clip. It's currently 38 degrees, maybe 37 degrees. Yeah, slightly warm at 6 amps. Still holding at 6 amps. So yeah, I mean, I quite like these spring clips, and I think this is quite a robust design. It can take the amperage, but in the event of a short circuit or a runaway, they burn out, as you've seen in my previous videos.